derivation of rate law equation. So given here is the general chain reaction equation for the reaction of one reactant that produce two products, which is A, reactant A, produce product B and C. And the mechanism of chain reaction and the rate equation for each step. So the definition of rate equation here is rate equation for each steps of reaction in chain reaction. Okay, so the mechanism is, so general mechanism, NIA, okay, any number of moles of A or any stoichiometric coefficient of reactant A will reacted to produce a radical species R. So the step that produce a radical species, we call it as a initiation step. So the first reaction is initiation step. Okay, then next step, second step, A plus radical R. Okay, when the reactant reacted with radical species and produce B plus C plus another radical. So from step 2, the reaction produce the product B and C. So the step that produce the product of reaction, we call it as a propagation step. So second step is propagation step. And finally, the third step, okay, NT, either it is number of moles or stoichiometric coefficient of the reaction, okay, for the radical species. If the reaction required 2 moles of radical species, of course, for the termination step, the reaction is between the radical species. So the last step, step number 3, actually the reaction between the radical species that produce X. X is inactive product. Inactive product. Therefore, the last step is termination step. Because the reaction involve a reaction between radical and it will produce inactive product. Okay, then we look at the rate equations for each step of reaction. For initiation step, Ri equal to KICA power of Ni, because we assume the reaction is elementary. So that's why concentration of A power of stoichiometric coefficient of A, which is Ni. Okay, and then for propagation step, Rp equal to Kp Ca Cr. And for termination step, Rt equal to Kt Cr, concentration of radical species, power of Nt. So Nt referring to the stoichiometric coefficient of radical species in termination step. Okay, so you can highlight here or jot down simple notes. Reaction assume elementary. So assume elementary for each step of reaction. Okay, then we want to derive the rate law equation for the overall reaction of A to produce B and C based on the mechanism of reactions given. Okay, so how to derive the rate law equation? Okay, derive the rate law equation. First, you need to write the mass balance equation for the radical species. Okay, first step, write the mass balance equation. Mass balance equation for radical species. Okay, only for radical species. To derive the rate law equation. Okay, so mass balance of radical R. So let's say direction occur in PFR. So dCr per dt, okay, concentration of R, change of the concentration with respect to time. So dCr per dt, and remember radical, we assume the radical is the intermediate product. So based on the rate law for each step, the first step, R produce. So Ki Ca power of Ni, only one R produce. And then second step, in propagation step, first radical will disappear. So when radical disappear, okay, in second step, so minus Kp Ca Cr. And then after that, when the reaction occur, R appear, formation of radical species. So we need to consider both. So plus Kp Ca Cr. Okay, later we cancel out. And then in the third step, R disappear. So minus Nt Kt Cr power of Nt. Okay, because we write the mass balance based on species R. Okay, not on species A. Okay, then second step. Or maybe we can simplify the equation first. So if we cancel out minus Kp Ca Cr and plus Kp Ca Cr, therefore dCr per dt equal to Ki Ca power of Ni minus Nt Kt Cr power of Nt. So this is for the first step. Alright, second step, we need to assume PSS approximation. PSS approximation is pseudo steady state approximation on the radical species. Why on radical species? Why we need to consider only for radical species? Because radical species very reactive, unstable, and low concentration. So that's why we consider the PSS approximation on the radical species. Alright, then assume PSS, meaning that the change of concentration. So assume PSS dCr per dt. Say only for radical species. dCr per dt will equal to 0. Okay, when dCr per dt equal to 0, therefore the rate equation Ki Ca power of Ni minus Nt Kt Cr power of Nt will equal to 0. Alright. Then, rearrange the equation. Rearrange. You will get rearrange for CR. Okay, rearrange for concentration of radical species. Concentration of radical species. Okay, not for reactant A. So we need to rearrange for the concentration of a radical species. Then we will get CR equal to ataupun CR power of NT equal to KI per NT KT power of CA power of Ni. Okay, then solve it. You will get CR equal to KI NT KT power of, because square of NT, so 1 over NT. So this one all about mathematics. Multiply with CA power of Ni per NT. Okay. Ni multiply. Okay. So this is the concentration of radical species. Alright. Finally, we want to write the overall rate law equation. Okay. Overall rate R actually equal to rate of propagation. Why overall rate equal to rate of propagation? Equal to rate of propagation. Because during the propagation step, it will produce major product. Okay. So, rate that produce major product. Right, so in this case, major product is B and C. So, rate of propagation is, so overall rate R equal to RP, KP, CA, CR. Okay, we have this rate. But the problem is, we want to eliminate term CR. So, the objective is to eliminate term CR. So all when you need to derive the rate law equation, when the rate law equation have the term of radical species, so you must eliminate it. Okay, so we want to eliminate the radical species term, concentration of radical species term. So that's why we derive the equation for the radical species from the mass balance equation and apply PSS approximation. Okay. So why we need to eliminate the radical term? Again, because of the very unstable and very reactive properties of the radical species. So we want to represent the rate law based on the stable species. Okay, then insert CR equation into the overall rate. So insert R equal to KPCA, then CR equal to KI per NTKT, okay, bracket power of 1 over NT. So later we rearrange back. CA power of NI per NT. Okay, then rearrange, susun cantik-cantik sikit for effective K. Then K I per NTKT power of 1 per NT multiply with KP, then combine for CA. So CA power of 1 plus NI per NT. So you need to know about mathematics juga to derive the equation and simplify the equation. And this term, okay, so this term is actually the effective K. K effective rate constant K, right? So this is the overall rate reaction equation for the general equation of chain reaction. Okay, but if you have the stoichiometric coefficient, you have the mechanism of reaction, just use the same steps to derive the overall rate. So start with mass balance equation for all the radical species involved in the reaction, followed with the assumption of PSS approximation for the mass balance of each radical species, and finally write the overall rate equation. And from the overall rate equation, we need to eliminate term for radical species.